Alright, guys. 10 minutes and I go live. Actually, I'm live now, so they can hear you. My students. Hello, everyone. Again, I'm going to start at 1:45, but I'll probably always start the streams a little bit early just to make sure the tech's working. So as people filter in, I'm just answering some emails. Again, these streams will start a little bit early. I will do the class time at the class time. Just so I can make sure the tech's working. As it progresses, I'll probably be able to start the feed right at 1:45, 1:30-ish, right? Something reasonable. We'll adapt. We'll figure it out. Ah! Oh! Sorry, testing things. All right. So There we go. See, there's my Boderon. Boderon. I hate when things are. There we go. I hate when things are flipped for webcams. I don't know why they do that. Right? It's not like a mirror. But I don't think you'll ever need to see my face in it, but it's here just in case. Alright. There's the slides. And there's the blackboard. We still have a delay time. I'm actually doing a delay time test here. So let me see here. I'm going to make a mark. Once I see this catch up, then I'm going to figure it out. Okay. So there's about a 10-second delay. That'll affect how we do questions. Okay. I think I got my tools just about ready. We'll see how the microphone volume goes. And we'll just wait as people come in. This is where I need to get like music or some type of hold music, huh? How does it feel hearing me type on my computer? Again, I will work on trimming the times better. I said I wouldn't start the stream until 1:20, but I was testing out stuff. Since I'm still even a minute before I said I would start, right? Alright. Alright, so as people trickle in at quarter of, I will start a lecture. We're kind of finishing our way through chapter 4. And I have homework due a week Sunday. The idea is that, well, I'll explain it all at 1:45. Just really want to keep noise going through here as I wait for the streams to start. I will figure out a way to do that. I know I can have the stream waiting, but I really wanted to test out some of the tools that I were using, because I've added the ability to switch. So you can see me with my headphones. Hi. My keyboard's in the background. Hey. And these are generally not for educational purposes, but here they are. Let's see, can I get my microphone in? My microphone's over there. And then I can do the slides. And I have a blackboard. And so these are all the things I'm trying to make sure are working well before we start with everyone at once. So that's what we got here. And we'll see where that takes us. Again, the delay time is anywhere from like a few seconds to a minute, depending on how you dance around the interwebs. Google's not doing a too bad job with it. So all my tests are in play. Yeah, I think in the future I'll open the streams at 10 minutes before class, and I'll leave it on a background thing. But such is life. Of course, I will repeat all of this at 1:45. So Julian and Jay will get to rehear all of this. Julian, Jay, and one other. That might be me. You might show my previewing window as a person. I am a person. Yay! Welcome back, Jay. As we did test delay times. Again, I'm not really starting until 1:45, but I'm going to keep talking. And in the future, I will make this window of awkward space much smaller. But I'm okay in the awkward spaces, right? Did not realize I was looking so rough. I'll definitely do something about the hair around the headphones. And yeah, definitely glasses glare. Right? We'll do something about that. It's also weird that what I look at versus the camera Doesn't quite. That's. Luckily, to learn stats, you don't need to see this. You can see this. Alright, I'm actually going to try to find a way to mute this, and I'm just going to leave the window up, asking people to say hi in chat. I'm going to get myself a cup of coffee, and I'm going to wander about till 1:45. Be well, everyone. Talk to you shortly. Okay. Alright, so I am now talking. Can you hear this? So if you can hear this, my audio is not working the way it should. Do you guys hear the secret message? Looking good. Okay.
The answer to number 5 is
This is weird.
yeah.
It really
It's kind of relaxing though.
It's something. Never thought in a million years.
Never thought.
This.
That's a dilemma.
Uh-oh, Jay can hear the secret message. So this is definitely not working. Hello! So still my mic is coming through. Oh well. I don't know how to fix that. Oh well, we'll work on it. And again, I'll cut this time ahead of things down as we go through. It's funny the weird hat head I have from having headphones on. All right. Well, I will find ways to mute. I hope my sipping coffee isn't too loud. This whole microphone thing's a bit weird. Alright. I'll turn up my volumes there, and that should be good. Hopefully, alright. Let's see, let me figure out how bad this is. Alright, so in about 10 minutes I'll get into the meat of everything. And like I said, in the future, there won't be as much dead time. Dun, dun, dun. Yeah, definitely couldn't find music to play through here. about 8 minutes, I'll get started for people hanging in the chat. So, just so you get an idea of the delay, I just saw Matt come in, said hello, Matt. So now I'm saying it here. I will try to repeat questions on the microphone as I see them coming across. I've only done this setup once. It was my earlier class today. I tweaked some things. Hopefully it'll be better. And we'll see what we can do with it. Definitely need a theme tune. Right. It's like waiting to watch an online newscast or podcast, and they have their nice little theme music and a logo coming in. My chicken's scratch on my electronic blackboard needs a theme. Like, maybe I'll just loop that. Jump over the keyboard, throw some soft pads down, and be like, but no. You've got some feedback going on. Okay, maybe I brought the gain up on the mic. Is that a bit better? Is it still feeding back on you? Testing. Are you getting a volume level? Are you still getting the feedback? Okay, I'm trying to listen from here, but I'm not getting any playback on my sound source. Give me a second here. We'll work on that. No, that's not my room. It's the audio is being duplicated somewhere. Now that when I listen to the stream, give me a second here. I'm going to change some of the audio settings. Okay. Let's see what we get here. All right. So I had done in a previous class, it was not giving this weird echo. I will try to figure this out for a second here. I'm going to disable the audio and try to come back in. Alright. Alright. So there should be no audio now. Yes, so it is completely muted. Alright, so that fixed that one problem. Let's try to bring it back. All right, now I have an audio and I have a volume. It's a bit low. Let me bring it up here. Interesting. All right, so I've got audio. Do you hear me? Jay, can you hear me? Julian, can you hear me? Trying, yeah, there's a lot going on here. All right, good. All right, so that actually cut off so much of the echo. I'm hearing it as if it's my real voice. Oh, that's better. Ah, thanks. And no annoying feedback on your end because it's gone on my end. All right. Woo! I like it when things work as they should. All right, in a minute I'll be starting and I'll recap everything I've been babbling about in the middle here. And I will have to agree, Matt. Learning at home can be interesting. I would love to get the technology a little more streamlined so that it is like being in person. It's close-ish. The thing I'm really working on is figuring out a way that I could hear you if possible. Because I think that'd be a better way of questions than chat, but that'll work for now. Yeah. FaceTime and Zoom, they're screen capture utilities. Well, FaceTime has a problem; you only have to be on a Mac to use it. But Zoom, FaceTime, Skype, their screen capture abilities aren't as um, um, robust as what I have here. So I have a virtual blackboard. I have a place to put the PowerPoints. And if you want to see me coming through, and I can switch between those things to keep things moving. Of course, right now, none of that seems to be going. Huh. Interesting. Let me see if I can get back there live. Yeah. There we go. I'm back into the live. All right. All right. So I'm going to start. So, in general, classes technically, and there's weird communication on this. I think you'll see some of the people that have the 093 Statway. Some of the professors have been assigning work due this week on it. The initial communication was if we moved to online, we would start classes this week. Now, I initially decided to do online and hello, Trevor. To do online and in class for people that didn't have online access. But then when they canceled on face-to-face classes, I switched to online. So what we're seeing here is what I would have done in the classroom. I would have pointed a video camera up at the blackboard and have done it just like we're doing now, except the people that couldn't access online would come into class. And the nice thing about the YouTube version of this it will record everything, and so when I'm done with it, there will be a link that we can go back to. You can go back to this lecture for notes coming across. So after having done this for one class, I'm slowly adapting some things in my settings, and you'll see that come through. So don't expect all the classes to be indicative of this, or this is a work in progress. What we're going to do is I'll present stuff as if it was in class, and I will use the chat for a place to get questions. I will use the Blackboard to run things on. I'll probably show the slides a little bit more than I normally do in class, and that was something that plus or minus on. I like explaining things off on the side. My ideal lecture space would be to have the slide on one side and a blackboard next to it so I could write out to it. And I did not have that capability with the way the room was set up. That said, we're going to do the best we can. We'll go back and forth. Being that I initially was set to do on phase, none of my due dates are going to be as if we started classes this week. I'm using this opportunity to record the material, get the material online. There are people that won't be able to come in here live, and there will be people that are. And so I'm going to record the material. It'll all be posted. People can see it. But the stuff being due won't start being due until next week. We were due to have an exam once we finish Chapter 4, which we would have done this week. So I was looking at next Thursday. Not this coming Thursday, but next Thursday doing an exam. I'm going to push that ahead 1 week. And it's going to be done online using the Pearsons online. I also have all your exams, and I'm popping those down on Blackboard. And I'm emailing anyone that has any concerns or anything that I have any concerns on. I will also be doing any of the in-class work that we did when we worked out with the president's ages, and a couple of worksheets I handed out that I wanted to work in class, which I handed to you on probability on Chapter 3 that we were going to do in class. I'll be putting those as quizzes online that you can go back and do. It'll be like homework, but it's very focused in particular questions. I'm probably going to move and kind of adjust the quiz activity grade into the homework grade, because the quizzes and activities were a conversation between us on what we needed to work on. Oh, hello, Kyle. Sorry, I wasn't looking at chat when I saw that. So I'm getting that updated on the syllabus. I have it mostly there. I'll share it with everyone on Blackboard. My goal is to get my Monday, Wednesday classes up to date today. I really did plan on being off on spring break, and so having to change some stuff here, I got everything set up so that we could be as if we were in classes, but none of the due dates start until next week. So on that note, I'm going to start talking about mathematics, but I'll say right now, does anyone have any questions? Let's see. So, it does not look like there are any from Julian. Wait a minute. Julian, you went from J. Holmes to Julian Holmes. That is very confusing, but it worked. All right. And everyone, let's go. So I'm going to do a very quick review of Chapter 4. So first I'm going to erase my Blackboard. And this will be something that will not cover me in chalk, which has me greatly disappointed. I really do like being covered in chalk. It makes me feel like I'm doing my job. But all I have to do is do that. And then I get to do that. Alright, and let me pull into here. So there I have a fresh Blackboard, but really we're going to be talking from here. And we talked about probability distributions in general. So I'm going to walk through probability distributions kind of as a refresher. And we're going to probably really start with the binomial distribution, which is the last thing I left you guys with, because the binomial distribution is a particular probability distribution. We're going to look at three particular probability distributions: the binomial, the geometric, and the Poisson, and how they get applied into certain situations. So I'm just going to do this quick run through of probability distributions in general, and then we're going to look at those three that come up. So one of the things I would say that in this section where it says more discrete probability distributions, that really is geometric and Poisson that we tend to use a lot out of those. And if you look at the end of section 4.3 in the book, it kind of has some good summaries that we'll come back to as they come across. Alright, so everything is based off the idea of a random variable. Random variables determine what we can or can't do. If I were truly measuring something in reality, there would be a randomness in all of that. And so we use random variables to describe what we're doing. Now, there are two types of random variables that we're going to look at. They're going to be discrete and continuous. Right? And so we're going to use the letter x. It was just the same variable that we used when we counted things or measuring things. And the relationship between randomly things generating themselves organically and naturally, which has a randomness to it, and then when we go to observe it and count those things, it's the same idea, just on opposite ends of the process. So when we're doing our descriptive statistics and we're counting what we saw, that's the other side of what we were counting as it naturally happens. And so randomness is that natural process of what happens. And this is why I've always kind of stated that when we go to measure things in our descriptive statistics, we need to make sure that we're choosing randomly, that we're choosing in a way that we don't get pockets of information that might not be descriptive of the whole thing. I've tried to emphasize randomness. And so we're going to look at random variables as a thing. And that's why we kind of did that whole chapter on probability of how do we measure random things. And so our discrete random variable was countable. We can count 1, 2, 3, 4, and 5. Or even we can count by halves, we can count by quarters. The thing that we measure comes in some base thing. There's a number attached to it, right? If I count money, US dollars, in general, unless you're in bank or high financing, you don't count the half cents. You count everything down to the penny because that's all you can exchange. Now a penny is 0.01 of a dollar. Right? It's not continuous because it has a decimal, but it's continuous, it's discrete because the smallest thing you can give is a penny, back and forth. The opposite of that are continuous variables. And continuous variables, I can measure better and better. That's my dog, Connie. So, 2 seconds here. Charlie, you gonna take her out? I think she might need to go out. Sorry about that. That's the difference of class at home, right? You occasionally get those interruptions. And there's not much I can do about that. Sorry. So a continuous random variable, my measuring determines what will happen. So if I get a better and better ruler, I can measure smaller and smaller quantities. I can measure, if we're looking at hours spent in one day, I have 0 through 24, but I can measure 24.0003 hours if I have an accurate enough clock. And I can always measure smaller, and so it doesn't come in a packet that's countable. And that's the difference between the two variables we're going to look at. I will say that when we look for examples, and I'll use the example here, the number of companies is discrete. You can count companies. While the amount, so there's five Fortune 500 companies. If we count how many of them lost money, there's not going to be half a company that lost money. But if I put in gasoline into a gas tank, if it's a 21-gallon tank, I have between 0 and 21 gallons I can put in, but I can put in 11.4389, down to however small the pump measures. And so out of these, we had our probability distributions. And the thing that I wanted to highlight in probability distributions was that all probabilities have to be between 0 and 1, because 0 and 1 represent 0% chance and 100% chance of something happening. So if something can either have no chance of happening, or it's guaranteed to happen with 100%, or somewhere in the middle. But you're not going to have a negative 3% chance of something, and you're not going to have a 500% chance of something. These have no meaning in the mathematics we have. So we limit any probability between 0 and 1. And then if I add up all the probabilities that go into a probability distribution, the total is going to be 1. If I have a probability distribution, it has to cover every possibility, so we're guaranteed to get a result. We don't just look at partial results. I need to know every possible outcome. And so if I add up all the probabilities, it comes to 1. Alright, and then we looked at how we calculated the mean for a probability distribution. Again, I'm going a little quick through these, and these are our notes from the last class. I'm just trying to get on the same page here. So if I'm going too fast, just holler for a question. Sorry, dog came running through. So if we look at the mean of a probability distribution, it had this specific equation. We would multiply each probability by its count. And then add up those totals. And we did one of these in a graph. In fact, we did the example I'm going to walk through here in a second as an example. And we had to build columns for it to work. And so if we had this passive-aggressive traits that we looked at, and these were the counts on the scores. So if we came back here, let me see if I can find the example that I used. We had a test that was given, and the frequency of the results in the test. So you could score 1 through 5 on a passive-aggressive test. If this, again, we ran this through in class. So I'm highlighting it. These were the scores and these were the frequencies. And we calculated what the probability was for each one, which was, let me see if I can find them here. If we added up the total number of events, there was 150. And we divided each by the count. We had the probability of getting 1 score out of that. Now notice this is very discrete. There's only 5 answers. You're going to have one of the 5 answers only. So we had this information in this table, and we turned that into this. We had the value of the score and the probability that you would get that score. And so if we take each one here and we multiply it. So I'm going to come over here and bring this out. So I am writing on the blackboard right now. I will pull that over in a second. I am just copying the graph, and I will be right back. So 0.16. The dog did not want to go outside. Charlie just got her outside. That was the scuffle you heard. My apologies for that. 22, 28, 20, and 14. (22, 28, 20, and 14). Alright, so I'm going to switch views over here so we can see the Blackboard side of this, I hope. Alright, so if we wrote this graph here, and what we're going to do with it, or this chart, is we're going to make x times p of x. And that gives me 0.16, 0.44, and this time I actually am remembering to bring the calculator with me because it's just down on my dining room table. There is a convenience about that. 0.84, 0.80, and 0.60. And so we made an extra column in our data. And then we summed up this column. Because if I sum up this column, it'll be a sum of these probabilities. And did I mistype anything in here? Come back. Let's see, 14, 20, 28, and 16. 16, 14, 20, 28, and 16. I multiplied wrong. Let's see. Times 2 is 42, 20. Yeah, this one here is 70. That should be 70. Now, if I add all of these up, I get 2.94. This is one of the weird things about this. Finding an eraser on this is a bit odd. That should be 0.70. My bad. And so we're able to find the mean by adding up the probabilities times everything. And so this is able to give us an idea of a mean of a probability distribution. Right, and that wasn't too bad. It was the next thing that we had to do, which was finding the standard deviation that comes out, because the standard deviation gets this lovely formula here. And so, well, let me plop that up here. Do apologize for the scene changes, but we'll go back and forth. And so our standard deviation, we had to do a sum of the data value minus the mean squared. This is very, very, very similar to how we calculated the standard deviation on its own, but notice we're adding the multiplication of the probability. So we're not dividing it by n like we did before. The probability does that for us. Because the probability takes into account the total number of things, we don't have to divide by n. The probability does that for us. It's the frequency divided by n. And so we would go back and we'd make another column. And what I'm going to do is I'm going to show the column as it looks like in the data, because again, we worked out this example and we got to where we needed to go. I'm just reviewing general probability distribution so when we can look at the binomial exactly. And so here you make a column for the x minus mu, and then you square that value and multiply it by the probability, which is what they showed there. Again, I would look at your notes. We worked out the x minus mu, then we did the x minus mu squared, then we multiplied it by the probability, and we added them all up. And these happen with those. It is good to make columns of data. And so let me go back to here, and let me see if I can get a fairly half-decent eraser going on. 2 seconds. I'm just scrubbing a bit of the board here. La 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 la. Alright, so I finally figured out how to make the eraser work. That's a good start with things, wouldn't you think? Alright, come back here. Yeah, alright, so. Alright, so let me show this up here. This will be the weirdness of switching between those things. Alright, so I got an eraser working here. So what we want to do is we want to have a column of x minus mu, then a column of x minus mu squared. And then finally you take this and you multiply it by the probability. And we sum that up. Again, we should have this in our notes. And that will give you the standard deviation squared. Now if I take the square root of that, in this case I get a 1.614, or I'm sorry, 1.61. Let me see if I can make the eraser work again, now that I've figured that one tool out. Yay. I'll get a bigger eraser at some point. And you can hear my tablet kind of in the corner. Sorry about that. Oh, this is almost like the blackboard. I'm leaving streaks everywhere behind me. Ha ha ha. Alright. And that was 1.614-ish. Again, I am going quickly. We did this through our notes. 1.616, right? Coming through, but they in their slide didn't include the 2 additional columns, which is why we worked it out. And so we have the ability to find the standard deviation from any probability experiment. All right, so that was the big thing that we did on Thursday before we left for spring break. And then at the very end of it, I introduced the binomial experiment. And I said, and I really wanted to go through some examples of binomial experiments and wanted to show a little bit more, but we were right at the end of time there. And so this is where I'm going to start with these in like detail, not as a summary. And so binomial experiments are experiments where there are 2 outcomes, a success or a failure. Let me get that over here. There we go. And so a binomial experiment has a success or a failure. And that lets us kind of compute the probability of distinct things happening. So there's a fixed number of trials. I'm going to go 5 times, I'm going to go 10 times, I'm going to go 20. There's a fixed number of things I'm going to do. And each time I try it, it can either be a success or a failure. We know the probability of success. Well, of course, at the same time, we'll know the probability of failure. If I have a 70% chance of succeeding, I have a 30% chance of failing. So the 2 things kind of come hand in hand on a binomial experiment. Aisha, I see your question now. Did you discard the 2.94? Um, I'm not sure what you mean. A little more detail on that, and I can help. 2.94. Was that in the... Alright, so I'm typing in here because this is where the delay comes into a factor. We'll work with it. And going through. So, as I look for a follow-up on this question a bit more, in binomial distributions, you've got two options: success, failure. That's where the binomial, like bicycle, comes into play. And the probability of success and failure are related to each other. And so the random variable counts the number of successes. We're randomly thinking how successful we are. And so what we did is we translated all of this. We can translate all of this into a variable for a formula. And what we use are these symbols. We use the letter N for the number of things, how many trials I'm going to do. We use the probability of success for a single trial as P, and we use the probability as failure as Q. I don't know why they came up with Q. Most of these make sense until you get to Q. I guess it's the next letter after P, right? So it's the other probability you needed in this. Notice that Q is 1 minus P, right? Or 100% minus your probability of success. And then in your random variable is going to be, hey, how many of these did I get right? Did I get 0 right? Did I get 1 right? And you do that for every possibility until you get up to the total number of trials. So what we want to do is set up so that we can have a probability distribution that is based off of these two factors, getting it right or wrong and counting the number of successes, because that's something that is predictable in the probabilities, and so it becomes predictable in what we can do. Sorry, as I'm cleaning off my blackboard here as coming through. So I'll just pull on the next one. So if you want to decide if something is a binomial experiment, what it needs to do... Oh, yes, the 1.616. Sorry, Aisha's question came through, came out from the square root. Yes, that is correct. I apologize. Coming through again because we had done it in the notes before. I went through it really quick to the end. I tend not to think of what they call the variance, which is the standard deviation squared, as much as I think of the standard deviation itself. So you'll see me ask for the standard deviation more than the variance on that. So that was Aisha's question coming through. And notice this is kind of how the delay times are going to work with the chat. I will work on getting the delay times down and try to be a little more flexible on how we found some things. So if we look at things that could be a binomial experiment, we have to figure out, is there a set number of trials? And if we look at a set number of trials, okay, so I'm answering Aisha's question here. The 1.616 is correct. I will add up the column and add it to the notes. All right, so I just got 1.714 when she added up the squared columns. I don't recognize that number, and I don't have my note from when I did it on the board there. I will pull that up and re-verify that. So I'll redo that table, and I'll either scan it or plop it up kind of after this lecture. And being off by, it is probably one of the squares is off by a decimal point is what it looks like. That type of coming off by one in a square root might mean that one of the decimal points is off. That's what it looks like here, but I'll pull up from there. All right, so here is the experiment we have. So if we're looking at this, we need to make, does it satisfy the binomial experiment, which means is there a set number of trials? Does each trial have the same probability of success? And then what would be the random variables? So in this case, well, there's 8 trials, right? Because there's 8 surgeries being done. If there's an 85% chance on each, it's the same success rate. So this would satisfy the binomial experiment because there's a success or failure, the probability is 0.85, and the random variable counts each number of surgeries. So this meets the criteria. So we're going to be able to mathematically examine this because it meets those criteria, and it will, for anything that meets those criteria, the distribution of the randomness is the same. Based off of the numbers coming through, and that's what we want to look for in data. Is we want to look for a pattern that is the same, so that we can go through. So if we convert all of that information into the variables we have that there were 8 trials. That's each surgery. The probability of success is 0.85, and the probability of failure is 0.15. There will be 9 different possibilities for the random variable. And they don't say this in the book, but it should be noted that your number of random variables is the number of trials plus 1. And I hope you can see it from here. If we look at these numbers here, right, we have 0 being successful. There is a chance that none of these will be successful. Completely randomly, there is a chance that none of them will be successful. Then in 1 success, 2 successes, 3 successes, 4 successes, 5 successes, 6, and so on. And this means exactly 1 success, exactly 2 successes. And so if we want to examine the probability of 3 or more being successful, we have to figure out the probability for all of these and add them up. Because probabilities would be additive. But for right now, we have now a pattern that we can look at, and that we can, if the experiment matches it. And so I'm going to jump back up here on a slide and go back to what we're looking for, right? There's a fixed number of trials. So when we see our experiment, is there a fixed number of things? There's only 2 outcomes. It's going to work or it's not going to work. For each time I try it, the probability of it's working is exactly the same. It's not dependent. Trial 1 is not dependent on trial 2. They're independent. And then from there, hey, a random variable will count how many times it's successful. So if we can get a fixed number of trials, it can either succeed or fail, and the chance of success is the same for each trial. There's no dependency on the chance of success. We can use the binomial distribution. And the binomial distribution ends up looking uglyish. This is the formula for it. And so what I want to note here is this is our friend combinations. And x is the random variable we're looking at, and n is the number of trials. So when we pull into a particular probability distribution, we will look at, particular binomial distribution, we will look at the chance of 2 trials, exactly 2 being successful. 3 trials, exactly 3 being successful. These are things that we can look for. Now, we can do this calculation by hand, or we can use our technology to do it. And so notice all those variables we set up come in here. And I think a key thing to note here is that the number of trials, or the random variable, becomes the power. And so if you have your TIs, it's very, very useful to use the probability distribution in the calculator. What we're going to do is we're going to look at this one, and we're going to turn it into a binomial distribution because it's small enough we can look at all the different probabilities here. And so first off, we're going to go, hey, is this a binomial distribution? So do we have a limited number of trials? So rotator cuff surgery has a 90% chance of success. Surgery is performed on 3 patients. Find the surgery being successful in exactly 2 patients. So it's saying that the rotator cuff surgery has a 90% chance of success, which is completely independent. So we do have a independent probability, and we're going to perform it on 3 patients. So that's a set number of trials. So if I come over here, and I look at this, my number of trials is going to be 3. My probability of success is 0.9, and my probability of failure, I think this is why I don't like the q's as a variable. They look like 9s if I don't give them the tail. Well, 100% would be completely successful, so my chance of failure is 0.1. Now my possible random variables are 0, 1, 2, and 3. And so we're going to try to look at all the different probabilities. Now the question is asking specifically, what are the odds of getting exactly 2? But we're going to work on the whole distribution. We're going to look at all 4 possible outcomes and see what that does for us. So the first thing I'm going to do is I'm going to look at the probability, capital P. I guess how can I make capital P larger? I think I'll just make it bolder for capital P. The probability of 0, the probability of 1, the probability of 2, and the probability of 3. Now the question is specifically asking for the probability of 2, but we're going to look at each one and how we can process them. So in general, the probability of x is equal to n combined x p of x q to n minus x. Now this we have a key for in our calculator, and the rest we can calculate out. So if we were to look at what we were going to be entering on the calculator, n is 3, so I have 3, choose 0, 0.9 to the 0th power. Whoops, I don't want to write that as q. I want to write it as 0.1, 0.1 to the 3rd power. So notice what I did here. I looked at my variables, and for each one of these probabilities, I'm going to substitute it back in. So I have 3 trials, that goes in for my n. My random variable is 0. My chance of success is 0.9 to my random variable. My chance of failure is 0.1 to n minus my random variable. And so we'll look at that in the calculator in a second. This one, I'm still going to have 3 trials, but I'm going to choose one. And so my 0.9 to the first, 0.1 to the 3 minus 1, which is 2. So I'm setting up all the different odds I have for each of these values, what are the different probabilities, and then we'll look at the distribution they create. And so I still have 3 trials. 2. I'm going to have 0.9, 2, and 0.1 to the first. And then for my last one, I have 3, choose 3, which will give me 0.9 cubed, 0.1 to the 3 minus 3, right? 3 minus 3, which is 0. Alright, so let me see if I can find a calculator. Coming across, I have my TI-84. I'm looking for my TI-30s since I know there are some TI-30s out there. Now I will try to find this on a TI-30 in a second here. But for right now, we're going to look at the TI-84. They all end up entering the same way. So I'm going to just look at the first one and how we would enter it. And so you always need to use your probability function and your NCR. And so you would enter 3. NCR 0. So 3, you hit the NCR function on your calculator, and then you type in 0. Then you would type in multiply, and I would use parentheses, 0.9, up arrow, 0, multiply, 0.1, up arrow, 3. So that's what you'd put on your calculator. Now on the TI-84s, the NCR key is in the math function. You'd hit the math button and go over to PRB and scroll down to NCR. You need to type the number 3 first. On the TI-30s, you'd hit the PRB key, go over to NCR. And again, you need to type the number 3 first to do that. And so that would give you the ability to find that. But I'm going to run through and plop out the answers for these right now. What's nice is on most of the calculators, you can use the up arrow to go in and re-enter your information. So once you have it entered in once, you can go back and change the things that change on this. And I just want to make sure that I'm getting enough decimal points out of this. Alright, so I got for this 0.001, which is approximately 0.1% chance of everyone not having a successful surgery. Come back here, let me update my variables. So let's see, 3, 1, 1, and 2, and I get a 0.027, or a 2.7% chance of only one person successfully having rotator cuff surgery. go back here, re-enter my variables. So I keep scrolling up and just changing the numbers that have changed. And so we should note the numbers that change are this one and these two. So once I have one entered in, I can just up arrow and change this number and these two. And that should keep giving me the answers I need to get the whole distribution. And yep, 0.243, or approximately 24.3%. So notice how the odds of completely failing with a 90% chance of success are really low. And how the odds are increasing because the chances of success are extremely large on this surgery. And so it lets us have a look at going through. So if I do this last one, it's 0.729, or 72.9%. And so notice, right, the high chance of success doesn't mean that all three being successful are 90%. What happens is that percentage applies to each patient individually, but there's randomness involved. And so the randomness manifests itself as these particular values that would come out. And this is a probability distribution. These four results are the only results you can see for three patients. And so you have a probability distribution. And I'm going to just very gently in the corner here graph it. Right? This is down here below 1% for 0. And then in somewhere around 2%, so I'll make it here, is one success. 24% is going to be up here for two successes. And then that's a big one. It should be 3 times this, roughly 3 times this, not quite, for 3. But this whole distribution, and I'll color over the answer there, it's okay, right? Will look like this. It's skewed very far to the right, and that skewing becomes because the probability of success is very high. If the probability of success were very low, it would skew differently. And this is what a probability distribution does. But for any 3 patients that I'm running this trial on, and we're going to do this operation, we're going to do it on 3 patients, the odds look like this, always, coming across. And this is how a binomial distribution displays itself or works itself out in data. Now, one of the things that can happen is the binomial trials that we get very, very large. And so there are tables for binomial distributions. The book has in table 2 in the appendix. There's a binomial distribution. I will make the nice thing is, because we're now in an online format, all of these things are open book. Though, to be honest, it's very, very, all the exams we'll be doing will be open book. But I let you use the front tables and equations from the book. One of the things that happens is those tables didn't have a binomial and a Poisson distribution. They had normal distributions. So I don't have to print out copies of these in front of the exam. You'll have them with the book. But looking them up in the table is a little bit easier than calculating them. And so what I'm going to do is show you how to use the table. Now, in this particular book, in Appendix B, Table 2 shows you how to find a probability distribution. We're going to look at these values again from that, but let me just try to get that up on the screen here. Boom. There we go. I think this is it. Oops. I hope that wasn't it. That tried to move it down. Yeah. I'd come over here and switch this. All right, so this is what the table looks like, and this is a probability for 10. 10% chance of success. And now these table 2s are on there. Notice how they have the different n values, and then they'll have the different random variables. So over here we have the value of n, right, the number of trials, and then it reads the probability for each possible random variable. And so if we look at what they're asking to find here, they're saying 10% of workers in the United States commute to their job by carpooling, right? So if you select 8 people, so you're going to have a trial of 8, what's the probability that exactly 4 of them would carpool to work? So you come to the table here and you come to the cross for your probability, and it's a 10% probability of success. And so you come down here to 8. Now the section for 8 will have between 0 and 8 because there are 9 random variables for 8. And you find where the two things meet, and you'll find that you have a 0.5% chance of 4 people, or half of the 8 people you grab, having carpooled. And a lot of this has to do with where we are with the 10% data and such. The 10% success rate coming across. Sorry, my screen just gave me an update, and I double checked to make sure you were still with me, and you appear to be, ish. And so this is how we can look these up from a table. I would also recommend your technology. Now on the TI-30s, the only thing you can do is use that NCR calculation to get those. Thanks everyone. It's very reassuring, and the delay is not as long as it was for the previous class. So small steps. On the TI-30s, you have to use the NCR function to do these probabilities. If I find my TI-30, I didn't have it here, I might take my webcam and do a little video of doing the one I just did there on the TI-30. And I'll do the same thing with the TI-84. But the TI-84 has a nice a feature for it, and that's what I want to pull into. As it was in the book, yeah, it's back here. And so you can see, if you look at the TI-84 Plus, there is a function called the binomial probability distribution function. And I was trying to find that. I think Jay, you had a TI-84, but I couldn't determine if it was a plus or not when we were looking at this. But if we go into, I did not have this in my math functions on mine coming through. So I did not see where you could find these, but I know that they were typable. That's not a proper word, but let me just, I will definitely get my webcam working on a calculator, and I'll have a calculator on the side, because in this point in class I'd walk around and I would play with your calculators to make sure we were seeing the same things. But let me make sure. I'm going to type here for a second, so you'll hear me go quiet for a second. Yep, I'm still typing in the background as the sirens go through. Oh, that is Bennington. Alright, so B I and I guess this is the crime of different technology always doing things slightly differently, which is, and I find it really upsetting because Texas Instruments, that does all of the calculators, does it slightly different on all of the calculators. And so you kind of have to go through their manuals. And they used to specialize. You would get stat-based calculators and scientific-based calculators. And so that specialization meant that they did their keys slightly differently. In the end, over time, people got used to them, and it created all these different commands. And so I'm used to the calculators I have for very specific things that I've used them for, and when I go to do different things. Alright, so I am going to sit down with the manual for the TI-84 and figure out how to use their binomial PDF function. It does not work on mine. I found it. Alright, so I'm going to put this up on the camera. I apologize for the weirdness here. It was not where I thought it would be, but this might help. Okay, so let's see if I can make this work. Hello. Alright. So there's my TI-84. Let me see. Trying to get some light on it. Here's the second key. And over the vars key is something called distribution, D-I-S-T-R. If I go to second and D-I-S-T-R, I get a list of distributions. And I think I've got some glare here. I'm trying to get rid of the glare. There we go. And if I scroll down through this, there's my binomial PDF. So for the TI-84 pluses, you want to hit the second key and then the distribution key, and then you have to scroll down. It's the 11th thing down on there. Alright. Sorry for the awkward handshaking. It wasn't perfect, but it was doable. And I will get a good light source so that works out a little bit better in the future. And so you can calculate those on the TI-84s. The TI-30s, which are the little solar ones, you have to use that NCR key to do it, coming across. And the format of the command is right here. Right, like this. Alright. And so this is the format of the command. This is your N. This is your P. And this is the X variable you're looking for. For most of the things you do, the tables will work out fine. The calculators work out fairly well. I'm glad it was helpful, guys. It's hard, and I didn't expect to be doing that. I will work on. And we know calculators are part of this, and using our calculators we'll work through. When I find the TI-30, because I cannot find mine right now, I will do a similar thing for the TI-30. Okay, I know Aisha, you have a TI-30, and I know a couple of you in there. Matt, you had like a TI-30, slightly different one, if I remember correctly. Again, trying to remember everyone's calculators. I think, Julian, did you have an Nspire that works similar to the TI-84s? And that's about as good as my memory is right now. I'm seeing seats and different calculators on them. I'll do my best to use as much, but I only have a TI-84, a TI-89, and a TI-30, and I don't know where my extra TI-30s are right now. So I will try to work on that, and that's probably something in the future that I will use. Yeah, Matt, yours was a TI-30XS, but not with the 2, so your probability keys were above. Oh, Julian, you have the 84 plus. Okay. All right. Well, and again, I will do the best I can with the tech there. The nice thing is some of the stuff already exists on YouTube. I don't have to recreate it all. I try to find it. But that is what we'll use between using a table and using that. There's only one other thing I want to do with the binomial distributions before we finish for today, because that's all I'm going to talk about is the binomial distributions. and move from there. That's right. Yeah, your stamp buttons were odd, Matt. Yeah. I will see what I can find YouTube wise. You might need to look on YouTube to see if they have a binomial PDF. My guess is any of the 30 XS's, the XS2s and the 30XS, you'll have to use the NCR function like we did in probability. And so you'll have to do it. Let me switch my screen here for a second for you here. You'll have to set it up like this, where you enter the number 3, then you hit your NCR key, then you enter the 0, and you put the whole multiplication in. You'll have to work it bit by bit for those on the TI-30s. That's the only way I've been able to do it on the TI-30 XS2s, and I suspect yours is the same way on that. But it's worth a shot to see if the TI-30 XS has a binomial probability distribution function on it. All right, back to here. These are some other things that come out of a binomial distribution, and it actually becomes really, really easy-ish to calculate the mean and the standard deviation. Because notice here on these equations, the mean is just the probability times the number of trials. So if I come back to this example here, and let's see if I can give myself a little space. I might need to scroll over a bit. Okay, I'm going to erase these bottom probabilities and my really bad but workable graph, and we'll move from there. So let's see if I can erase all this fairly quickly. There we go. It looks like an eraser even. Sorry for all the clicking noises on the keyboard. I do have the mic on a mic stand, but it has to sit on the table. I do have a larger boom stand that I might try to put through. From what I'm hearing, the sound isn't too bad. Okay, it really does look like me on the board. I do kind of like that. There's a nice familiar feel to the way that looks. Doesn't that look like my eraser? All right. What? It's true, Julian. It's true. All right, so our mean for this particular well, I'll see if I can get a plug-in that I can put fingerprints on. I'm sure that they're there. Well, I'm glad the sound is 7.5 out of 10. I mean, you do get the doors in the background. There's nothing I can do that. Not Jim Morrison doors, but the doors in the house. So our mean, oops, that's the wrong pencil, but let's go down to here, is equal to n times p. And so for this data, I would have 3 times 0.9, which is equal to 2.7. And if we looked at the distribution I drew that was skewed to the right, the mean would be around 2.7. In fact, I'll redraw this distribution down here. That was the less than 1%, the few percent, that was 0 and 1. 2 is about 24% of the data, so about there. And 3 was 72% of the data, so like this. So, sorry, it's a quick graph. I will get better on my graphs as going through. And so the mean is somewhere around here, somewhere around 2.7. That does work out nicely for this. And then our standard deviation is the square root of NPQ. So the square root of n, whoops, Got excited there. NPQ. And so I'm going to have 3 times 0.9 times 0.1. And then I'll take the square root. So 3 times 0.9 times 0.1. And I have a standard deviation of 0.52. I'm going to round to the second decimal place, 5.19. And so binomial distributions we're able to describe fairly well from the data. And so these equations that we can use out to describe how binomial things work. All right, so that's all I wanted to discuss today was fully complete the binomial distribution. On Thursday, I'm going to look at the geometric and the Poisson distribution. So I'll go, are there any questions for right now? And we'll see if we have any questions coming through. All right, well, you're welcome, Matt, and you're welcome, everyone else. I'm going to end the stream, and then I'll post the link back to the recorded video. In the future, I won't have as much time waiting for this to come in, and the homework going up will be all of Chapter 4, and it'll be due 2 Sundays from now. We'll finish talking about Chapter 4 on Thursday. And then we'll look at, I'll set an exam time for chapters 3 and 4, about 2 weeks. I'm sorry, yes, I saying Thursday and I mean Wednesday. You know I do this, right? You're the Monday, Wednesday class, not the Tuesday, Thursday class. Wednesday. I will record a lecture as if we had class. I will have it open for you to come in and ask questions. But you don't have to. I will save and put the links there. I have found that people asking me questions have made this a lot more useful. I probably never would have used the webcam. And yeah, everything's online for the rest of the semester, Julian. Coming across, we will be doing everything online. All exams, everything online. So I'm going to end the stream now. If you have any questions, email me. I will post the links out to this. And I'll continue to do updates. I will be rewriting the syllabus that will go out tonight, just really marking on how we changed here. Thank you all for coming. Well, if you want to walk the dog, I think what I'm going to try to do is get that I'm aiming for an afternoon thing to take her on our walkie-walkies. I might have to become a morning thing. But I've got 4 boys here. They're actually sitting doing their homework in the living room. They should have walked her. She ran away from Charlie, and that's what you heard was her scurrying around. She was playing instead of going out. Sorry, not much I can do about that, but I think all things considered, it's not bad. Be well, be safe, and I'll see you Wednesday. Otherwise, email me if you need anything. You guys are great.